Hi all. In this class we can see what are the different attenuation in waveguide. So mainly the attenuation in waveguide are classified into two. So the power loss happen in two ways in waveguide. What means losses in the dielectric and another one is losses in the guide volts. So we can see one by one. So in general we can see that the total attenuation is attenuation due to what? First one is attenuation in the dielectric media. If the dielectric media is not perfect, then there should be attenuation and guide walls. So we can represent this guide walls attenuation in the guide walls. We can represent as lambda alpha c, and that of dielectric we can represent as alpha d. So the total attenuation we can represent alpha c plus alpha d. So we can say that this alpha z and alpha are attenuation constant due to ohmic or conduction losses and dielectric losses respectively. So this attenuation in conducting walls is due to imperfect conduction, or we can say that this conductivity is not equal to infinity, and dielectric losses is due to imperfect dielectric, that means conductivity not equal to 0. So that's the reason. So we can see that to find, first we can find what is alpha d. So we need to find the alpha d, we need to remember the equation for gamma. So for a lossy dielectric we need to find the fact that sigma naught, we need to incorporate the fact that sigma naught equal to 0. So our equation, so usually we are using the equation gamma equal to j beta if alpha is 0, but actually alpha for lossy dielectric, for due to this two reasons, alpha is not equal to 0. So we need to include that alpha terms together with this gamma. So gamma we can write as alpha plus j beta. So here if we are considering the dielectric, then we can write gamma as alpha d plus j beta d. Then which is equal to, we know the equation, root of m pi by a whole square plus n pi by b whole square minus omega square mu epsilon c. So that is gamma of a waveguide. Then we can see that this epsilon c is the permittivity of a conductive media is equal to epsilon minus j into sigma by omega. So the equation for epsilon c is epsilon minus j sigma by omega. So we can replace this equation and we can square this equation number 12.56. So you will get gamma square is equal to alpha d minus beta alpha plus alpha d plus j beta d whole square, which is alpha d square minus beta d square plus 2 j alpha d beta d. So after squaring the right side, you will get it as m pi by a whole square plus n pi by b whole square minus omega square mu epsilon c, where omega square mu epsilon c changed as minus of omega square mu epsilon plus j omega mu sigma. So we can replace 12.57 in 12.56 and we are squaring both sides. So you will get the equation. And we can see that for equating real and imaginary part, so we can equate the real and imaginary part on both sides. So the real part here is alpha d square minus beta d square is equal to m pi by a whole square plus n pi by b whole square minus omega square mu epsilon. Equating imaginary part, you will get 2 alpha d beta d is equal to omega mu sigma. So that's our two equations. So equating real and imaginary part, we will get alpha d square minus beta d square is equal to m pi by a whole square plus n pi by b whole square minus omega square mu epsilon. And while equating imaginary part, we will get 2 alpha d beta d is equal to omega mu sigma, or alpha d, from that we will get it as omega mu sigma by 2 beta d. So first we can find beta d, then we can find, after substituting beta d expression, we can find alpha d. So to find this beta d, we are taking the assumption that this alpha d square minus beta d square is nearly equal to minus beta d square itself. That means we are taking alpha d square is very much less than compared to beta d square. So we can see that this equation, real part equation, become minus beta d square equal to m pi by a whole square plus n pi by b whole square minus omega square mu epsilon, or beta d square is omega square mu beta d square equal to omega square mu epsilon minus m pi by a whole square minus n pi by b whole square. In this minus of m pi by a whole square plus n pi by b whole square is together known as omega square, omega c square mu epsilon. So we will get the beta d as root of omega square mu epsilon minus omega c square mu epsilon. From that we can take this from this root we can take omega square mu epsilon outside. So you will get it as omega root mu epsilon into root of 1 minus omega c square divided by omega square, where omega c is 2 pi f c, omega is 2 pi f. So we will get it as beta d is omega root of mu epsilon root 1 minus f c by f whole square. So that is beta d. So after getting this beta d, we can find alpha d as omega mu sigma by 2 beta d, that is omega mu sigma by 2 into omega root mu epsilon into 1 minus root of 1 minus f c by f whole square. So that omega cancels. So there should be omega root of omega by mu and mu is there. The numerator we have 1 mu and the denominator we have root mu. So you will get it as root mu by root epsilon there. Then remaining is sigma by 2 root of 1 minus f c by f whole square. In that root mu by epsilon is known as eta dash, characteristic impedance of the medium. So you will get alpha d as sigma eta dash divided by 2 root of 1 minus f c by f whole square. So this is called attenuation due to imperfect dielectric. Next we can see what is alpha c, that is what is the loss in conducting volts. So for that general equation we can take this general equation for loss in conducting volts is alpha is equal to, or alpha c is equal to PL divided by 2P average. PL is the power loss, so power loss divided by 2 times power average is called as alpha. So this using this Poynting's theorem we can write this power average is E cross half E cross H. Then we can replace H as E by eta. So you will get half E cross H is replaced as half E cross E by eta. So you will get it as half. If you are finding the modulus only, then you will get half modulus of E square divided by eta. So we can find the total power averages H equal to 0 to full. In that rectangular waveguide, in complete rectangular waveguide, we can integrate this power average to the entire length. So you will get it as integral x to x equal to 0 to a, integral y equal to 0 to b, EYS modulus EYS square divided by 2 eta dx dy. So after integration and replacing this EY component of rectangular waveguide, you will get the power average as omega square mu square a cube h0 square b by 4 pi square eta. We need to replace the expression for EY that we studied earlier. So we can replace that expression here. So you will get it as P average is equal to omega square mu square a cube h0 square b divided by 4 pi square eta. So the total power loss per unit length in the volts. So we have different boundary conditions. For this entire volts we can find it as power loss. Power average we found. Next we can find the power loss PL. So PL at y equal to 0 plus PL at y equal to b plus PL at y x equal to 0 plus PL at x equal to a. So that you will get it as 2 times PL at y equal to 0 plus PL at x equal to 0. So to find this, we can take this PL, first we can find PL at y equal to 0, then it is half into real of eta c into integral of hzs whole square plus hzs whole square ds, hxs whole square plus hzs whole square dx at y equal to 0, that is power loss at y equal to 0. So after integration and substituting zs and hxs, you will get it as rs a h0 square divided by 4 into 1 plus beta square a square by pi square. Similarly, we can find what is PL at x equal to 0. So that is half real of eta c into integral hz square dy. So at x equal to 0, so you will get it as rs b h0 square by 2. So the total power loss is the 2 times of addition of these two, PL at y equal to 0 plus PL at x equal to 0 into 2, that is P load. So we can write it as, after finding this, you will get it as RS H0 square into P plus A by 2 into 1 minus 1 plus beta square A square by pi square. So we will get the total power loss as RS H0 square into B plus A by 2 into 1 plus beta square A square by pi square. So we can say that alpha C is PL by 2 average. So we can replace PL equation as well as P average equation. So you will get it as alpha C is RS H0 square into B plus A by 2 1 plus beta square A square by pi square into 2 pi square eta divided by omega square mu square A cube H0 square B. So that is alpha C. Then alpha C, and we can represent in terms of F and Fc. So for TE10 mode, for the dominant mode of TE, you will get alpha C is 2RS divided by B eta dash root of 1 minus Fc by F whole square into 0.5 plus B by A Fc by F whole square. So for T other than this T10 mode, for TMN mode, we can use this expression to find alpha C, that is 2RS divided by B eta dash root of 1 minus Fc by F whole square into 1 plus B by A Fc by F whole square plus B by A into B by A M square plus N square divided by B square by A square M square plus N square into 1 minus Fc by F whole square. So that is the TE mode equation. Similarly, TM mode we can write as 2RS by B eta dash root of 1 minus Fc by F whole square beta by A whole cube M square plus N square divided by beta by A whole square M square plus N square. So these are the two conducting power loss happen in a waveguide, that is power loss due to imperfect dielectric and power loss due to imperfect conductor.